Alright, again, since we got this a little bit late, we're going to talk about finding measures of interior and exterior angles of polygons. I always start with the pentagon because it's a whole lot easier to deal with. I'll also draw a triangle because triangles are important, and I'll draw a quadrilateral. Now, we should know the sum of all the angles in here. The sum of the interior angles of a triangle is 180 degrees. So that's 180 degrees. Now, if we throw in a diagonal, which is a segment that connects endpoints through the figure, what you have to ask yourself is, how many triangles have I made? I'm going to say n equals 4, and that's going to tell me how many sides I have. How many triangles do I have? I have 2 triangles. This triangle has 180. This triangle has 180. So the sum of the interior angles is equal to 180 plus 180, or 2 times 180. Now, if I deal with the pentagon, I'm going to draw the diagonals from one vertex, and I see that I have how many triangles. So I know my n is equal to 5 sides. I know my number of triangles is equal to 3. And so the sum of the interior angles, I get 180 here, 180 here, 180 here. If you look at this angle, I have that part of it, that part of it, and that part of it, so I cover that entire angle. From here, I got this chunk, and I got this chunk, so I cover that angle. From here, I got this chunk, and I got this chunk, so I cover that angle. That angle's covered, that angle's covered. I've covered them all. How many triangles? There's 3 triangles. So I can say 3 times 180. Now the big question is, how can I use the number of sides to determine the number of triangles? So the number of triangles is going to be equal to, if I had 5 sides, I have 3 triangles. If I have n equal 3 sides, how many triangles do I have? I only have 1. So what's the pattern? If I have 3 sides, I have 1. 4 sides, I have 2. 5 sides, I have 3. Hopefully you see the pattern is, it's the number of sides minus 2, which is n minus 2. And then to get the sum of the interior angles, this is going to be equal to n minus 2, put that in parentheses, times 180 degrees. So that'll get me my interior angles for any polygon. So now if it's regular, you're going to do the same thing. N minus 2 times 360 will be equal to total sum. But all angles are congruent, so if I go n minus 2 times 180, that should be 180. Sorry about that. No Academy Awards for these videos so far. So if it's n minus 2 times 180 divided by n, the number of angles that you have there, this is the measure of one angle in a regular polygon. So there are basically two formulas that you have in here, and I'll highlight them for you. The sum of the interior angles for any polygon is n minus 2 times 180. The measure of 1 in a regular polygon, if it's regular, is n minus 2 times 180 divided by n. Now, for the exterior angles, let's take a square or a rectangle. It doesn't matter. Where I know they're all 90 degrees. Now, if I extend that side, extend this side, extend this side, and extend this side, if this is 90 degrees, together they have to be 180, so I'll take 180 minus 90, which is 90 degrees, so that's 90 degrees. Same thing here, 90 degrees, 90 degrees, 90 degrees. What do I get? If I add them all up, 90 times 4, which is 360 degrees. Now, take an equilateral triangle. Again, not drawn perfectly, close enough for government work. 60 degrees, 60 degrees, 60 degrees. Extend out the auxiliary lines from here, just like this. Together, you get 180. I have 60, so I'll take 180 minus 60, which is 120 degrees. So that's 120, that's 120, and that's 120. So the total is equal to 120 times 3, which is 360 degrees. Hey, 360 here, 360 there. Can we make a guess? Absolutely. The sum of the exterior angles of a polygon is equal to 360 degrees. That's nice, because all you have to do is remember a number. And it's basically like a circle. And if you think you're going all the way around the circle, you're covering every angle with that. Now, unfortunately, with regular polygons, everything's all messed up. For a regular polygon, we're going to go 360 divided by n is equal to the measure of one exterior angle. And even for a regular polygon, the sum is going to be 360 degrees. But if we want to find out what one is, you're going to have to divide it by the number of sides in your regular polygon. From what I've seen, this, I'll say, is ACT material. This, ACT material as well. So, go ahead, make sure you have those in your notebook, and you'll be good to go. Just really quickly, for Prove and this, check out the videos. Check out videos at Fordori Math. .weebly.com. Then go to geometry. Then files and videos. They're there. You can pick up on that from there to check that one out. Next page. I don't want to go too far or go too crazy with stuff. Use coordinates. This is the packet we did. And plus, there is a video. Woo! Same place as before. So you can get the packet and work on the packet at the website, or you can actually get the video and it'll show you what you need to do. You need to calculate distances, slopes, and you need to calculate distances, slopes, and midpoints. And let's see, get you guys caught up. Develop formulas. This is going to be after winter break. But if you want a preview of coming attractions, look at the trapezoid video. That might give you a heads up on where we're heading on that one. And then proportions and similarity. We're moving on from there. So hopefully this helps. If you have any questions, my door is always open. Send me an email or just kind of copy this stuff down. The notes are online as well. A little bit more in depth than this, but I just wanted to make sure you got this stuff for you. All right. Have a great day. Have a great break, and I'll talk to you later.